You've landed at the All Sorts podcast and prepare for takeoff. Today, we're soaring into a remarkable chapter of Canadian ingenuity, a story of blazing jet engines conceived and crafted right here, pushing the very limits of aviation, with the dream of supersonic flight within reach. It's a tale powered by ambition, innovation, and perhaps a lingering whisper of what if.
That's right. We're embarking on a deep dive into the history of Orenda Engines. It might not be a household name, but this company was absolutely foundational to the story of Canadian aerospace.
Absolutely. Throughout the mid-20th century, from the 1950s to the 1970s, Orenda wasn't just a supplier. It was, kind of the beating heart of Canada's aircraft engine industry, the primary source for both powering and maintaining our aerial fleet. Yeah. And for many, the mention of Orenda instantly conjures up the iconic, yet ultimately ill-fated, Avro Aero Canada's audacious leap towards supersonic flight.
A project that continues to ignite debate and capture our imaginations, for sure. Our mission in this deep dive is to truly grasp the pivotal developments, the significant achievements, and the enduring legacy of Orenda Engines.
Right.
We've assembled a pretty compelling set of sources for you, ranging from detailed historical accounts to insightful articles, and even intriguing glimpses into the physical remnants of their groundbreaking work.
Okay, let's unpack this. Where did this all begin? It seems the groundwork for Orenda was laid, during the intense pressures of the Second World War.
Indeed. The genesis of Orenda can be traced back to the National Research Council of Canada's vital aerodynamics research during the war. A particularly significant point was the 1943 Banks Report.
Banks Report?
Yeah, this report, stemming from NRC researchers who examined jet propulsion advancements in the UK, made two key recommendations.
And what were those crucial recommendations?
First, the report highlighted the urgent need for a dedicated cold weather testing center for jet engines, an area that, hadn't been adequately explored.
Made sense for Canada.
Exactly. Second, and perhaps more central to our story today, it strongly advocated for Canada to establish its own aircraft engine manufacturing capability as quickly as possible.
That makes perfect sense. If you're aiming to design and build your own advanced aircraft, having control over the development and production of its engines seems essential for true independence, right?
Totally. So following the compelling recommendations of the Banks Report, the Canadian government established Turbo Research as a Crown corporation in March 1944.
A Crown corporation? Basically government-owned.
Yeah, essentially a company owned by the government. They set up operations in Leaside, Toronto, using a section of the Research Enterprise's limited factories that wasn't really being used anymore.
Great.
This period saw the emergence of key individuals: K.F. Tupper as the chief engineer, Paul Dilworth as the chief designer, and Winnet Boyd, who initially focused on combustion tech and later also became a chief designer.
So Turbo Research was up and running, both figuratively and literally. What were their initial engine designs like? Were they starting from scratch?
Well, their early efforts concentrated on designs inspired by Frank Whittle's pioneering centrifugal flow jet engine.
The Whittle engine.
Yeah. If you imagine like a spinning fan throwing air outwards, that's the basic principle of centrifugal flow. They worked on a series, the TR.1, TR.2, TR.3, but these remained largely in the study and initial development phases.
So more theoretical at that point.
Pretty much. The team then shifted their focus towards a more advanced approach: the axial flow design, which they designated the TR.4, and subsequently named the Canuck.
Axial flow, that's a fundamentally different approach compared to centrifugal flow, isn't it? Is it more efficient for achieving higher speeds?
Precisely. Think of axial flow as channeling air straight through the engine in a much more streamlined way. This method becomes significantly more efficient at the higher speeds that jet aircraft are designed for.
Okay.
Simultaneously, there were major developments happening in aircraft manufacturing. The former Victory aircraft plants in Malton were being transformed into the new Avro Canada or Avro Canada plants.
Right, Avro. A big name.
Huge. This represented a significant consolidation of Canada's aerospace ambitions under one banner.
Okay, so you've got Avro building the airframes and Turbo Research developing the engines, both ramping up their efforts in the post-war era. But this model of a government-owned engine developer didn't last, did it?
No, it didn't. In 1946, the government made a strategic decision to transition away from direct involvement in engine development and pursue privatization. Turbo Research was subsequently sold to Avro.
Sold to Avro.
Interesting.
Yeah.
Paul Dilworth stayed on as chief engineer, and the organization became Avro's gas turbine division, relocating to the Avro plant in Malton, right next to what is now Toronto Pearson International Airport.
So the Chinook, this first jet engine designed entirely in Canada,
Yeah.
where did it fit into this evolving picture? Was it just a stepping stone?
The Chinook represented a crucial milestone, really. It proved Canada had the engineering talent to design a functional jet engine. It achieved its first run in March 1948, generating a respectable 2,600 pounds of thrust.
Sounds of thrust, that's the push, right?
Exactly, the forward-pushing power. However, only 3 Chinook engines were ever built because Avro's attention quickly turned to the development of a much more powerful engine, one that was urgently needed for their future aircraft design.
Ah, yes, the engine that would become almost synonymous with the Orenda turbojet itself. What was the driving force behind its creation? They needed something bigger, faster.
In the summer of 1946, Avro Canada tasked their gas turbine division, the former Turbo Research folks, with the ambitious goal of creating a significantly more powerful engine. They required an engine in the 6,500 pounds of thrust range to power their newly conceived CF-100 Canuck interceptor.
Le Canuck?
Yeah.
Designed for defense.
Yeah, designed to protect Canada's airspace from potential Soviet bomber threats. This critical requirement led directly to the TR.5 Orenda design, which was essentially a scaled-up and more powerful evolution of the earlier Chinook engine.
Scaled up, but still a remarkably rapid development process, wasn't it? Seems like they moved fast.
It was exceptionally fast. Prototype production was completed in less than a year, and the Orenda achieved its first run in February 1949.
Wow.
Then they embarked on an intensive testing program at a dedicated facility located outside Nobel, Ontario, interestingly. This site was a former munitions factory.
Repurposed, I'll say.
Between that initial run and the start of full production in the late fall the same year, the Orenda prototypes accumulated over 1,000 hours of rigorous testing, which was pretty impressive for the time.
That level of commitment to testing must have really paid dividends in terms of reliability and performance. You need that trust in an engine.
Absolutely. When the Orenda entered full production, it actually held the distinction of being the most powerful jet engine in the world.
The most powerful.
Yep, until 1952. By July 1958, an impressive total of nearly 4,000 Orenda engines across various developed versions had been delivered.
Wow, almost 4,000 engines. Where were these powerful engines primarily being used? Obviously, the Canuck.
The Orenda's primary role was in powering the Avro CF-100 Canuck all-weather interceptor, which served with distinction in both the Royal Canadian Air Force, RAF, and the Belgian Air Force, who were the sole export customer for the CF-100.
Okay, Belgian too.
But perhaps even more significantly, later, higher performance versions of the renowned Canadair Sabre fighter also adopted the Orenda.
The Sabre, like the Korean warfighter.
That's the one. They replaced their original General Electric J47 engines with the Orenda. This engine swap provided a dramatic increase in the Sabre's capabilities, making the Orenda-powered Sabres some of the fastest and most formidable of all the first-generation jet fighters.
And the Sabre itself was a very successful export aircraft, wasn't it? Didn't lots of countries fly it?
It was indeed a major export success. Orenda-powered Sabres were sold to the air forces of several nations, including West Germany, South Africa, Colombia, and Pakistan.
Really? So Canadian engines and German Sabres.
Yep. This international adoption further solidified the Orenda engine's global reputation for power and reliability. It's quite something to think that a Canadian-designed and built engine was powering frontline combat aircraft around the world.
It truly is a testament to Canadian engineering prowess.
Mm-hmm.
And the name Orenda itself has a rather evocative quality to it. What's the origin of that name? Sounds kind of mystical.
Orenda is a word from the Iroquois language meaning tribal soul on the right path.
Huh. Tribal soul on the right path. That's powerful.
It's a very fitting name for an engine that was intended to propel Canada's aviation ambitions forward with purpose and power. And the pace of progress was just remarkable. As you mentioned, the first run was February 8th, 1949.
Right.
The engine reached its design thrust by May 10th of the same year and had already surpassed 2,000 hours of testing by February 10th, 1950. Barely a year.
Incredible speed. And they even took it to the skies in a specially modified aircraft to gather even more real-world performance data, like put it on another plane.
Yes, absolutely. Flight testing commenced in July 1950 using a converted Avro Lancaster bomber.
A Lancaster from
Well,
WWII.
The very same. They replaced the 2 outboard Rolls-Royce Merlin piston engines with the much more powerful Orenda jet engines. This flying test bed accumulated an impressive 500 hours of flight time with the Orenda engines by July 1954, providing invaluable data on their performance and reliability in operational condition.
Must have looked pretty strange, a Lancaster with jets on the wings.
Probably did. So the Orenda was a clear and significant success story for Canadian aerospace. But then came an even more ambitious undertaking, didn't it? The development of the engine for the legendary Avro Aero Supersonic Interceptor.
The Aero. Here we go.
Exactly. In 1953, Avro Canada once again turned to Orenda, this time with the monumental challenge of developing a cutting-edge engine for the CF-105 Aero Supersonic Interceptor project.
A whole different level of performance needed, I imagine.
Oh, yeah. Initially, Avro had explored the possibility of using engines sourced from the United Kingdom, specifically the Rolls-Royce RB106, the Bristol Olympus, and a planned license-built version of the Olympus called the Curtiss-Wright J67.
But those initial plans ultimately didn't materialize, did they? Something went wrong.
No, unfortunately, both the RD-106 and the J67 projects encountered significant delays and were ultimately canceled during the Aero's crucial design phase.
Ooh, that's bad timing.
Yeah, it was a critical juncture for the entire program, as they were too far into the development to simply switch to the Bristol Olympus without substantial redesign and delays.
That must have placed immense pressure on Orenda to step up to the plate, like, okay, guys, it's up to you now.
It certainly did. But Orenda responded with remarkable speed and ingenuity, proposing and developing the PS-13 Iroquois design. It was a true testament to the depth of their engineering talent and capabilities.
The Iroquois, another great name. And the Iroquois represented a significant leap forward in jet engine technology, didn't it? Not just a bigger Orenda.
Absolutely. The Iroquois incorporated an advanced two-spool layout.
Two-spool, what does that mean exactly?
Imagine the compressor, the part that squeezes the air, having two independently spinning sections. This lets each section operate at its optimal speed, leading to much better fuel efficiency and overall performance, particularly when the engine is working hard.
Okay. More efficient.
And perhaps even more groundbreaking was the pioneering use of titanium in its construction. Approximately 20% of the Iroquois' total weight, primarily in the highly stressed compressor rotor blades, was made of titanium.
It's titanium that was truly cutting-edge material science for the time. What made its use so critical in the Iroquois design? Was it just lighter?
Titanium offers a remarkable combination of properties. It's significantly lighter than steel, yet possesses comparable high strength, and it exhibits excellent resistance to the extreme high temperatures and corrosive environments inside a jet engine.
Right. Heat and stress are big factors.
Huge. Engineers estimated that using titanium in the Iroquois resulted in a weight saving of around 850 pounds compared to using traditional steel alloys.
850 pounds. That's substantial in an aircraft.
Definitely. They also incorporated magnesium alloy for various gearbox casings to further reduce weight, and in cannel, a very heat-resistant nickel-chrome alloy for the turbine blades and the engine's rear insulation blanket where temperatures were highest.
So really pushing the materials envelope.
Absolutely. The overarching goal with these advanced materials was to minimize the engine's weight while maximizing its thrust and overall performance, aiming for an exceptional thrust-to-weight ratio, which is critical for supersonic flight.
And what kind of immense power was this technologically advanced engine capable of producing? We heard the Orenda was powerful, but this must have been next level.
During its rigorous testing phase, the Iroquois truly stood out as a world leader in terms of power output. It was officially rated at an impressive 19,250 pounds of thrust in its dry, non-afterburning configuration.
19,000. That's almost 3 times the Orenda's initial target.
Yep. And a staggering 25,000 pounds of thrust when the afterburner was engaged.
Whoa. What's an afterburner do again? Just dump fuel in?
Essentially, yeah. It injects extra fuel into the hot exhaust gases, giving a significant, albeit temporary, boost in thrust. The Iroquois was also aerodynamically optimized for peak performance at speeds around Mach 2 at an altitude of 50,000 feet.
Mach 2. Twice the speed of sound.
And during its extensive 7,000 hours of development testing, it even achieved simulated altitudes of up to 70,000 feet and a forward speed equivalent to Mach 2.3.
Incredible figures. They even managed to conduct some actual flight testing of the Iroquois, didn't they? Not just simulations.
They did. In 1956, the United States Air Force generously loaned an American Boeing B-47 Stratojet bomber to the RCAF specifically for the purpose of flight testing the powerful Iroquois engine.
A B-47 bomber. Why that plane?
Good question. It was available, large enough and fast enough, relatively speaking. Canadair, acting as the subcontractor, ingeniously mounted a single Iroquois engine in a specially designed external pod on the right side of the bomber's rear fuselage, close to the tail.
Just stuck on the side.
Pretty much. However, this modified B-47, designated CL-52 by Canadair, proved to be quite a challenging aircraft to fly due to the significant asymmetrical thrust produced by having such a powerful engine on only one side.
I can imagine. One massive jet pushing on one side must have wanted to constantly turn.
Exactly. Despite this, they managed to accumulate approximately 35 hours of valuable engine flight testing with this unique setup.
One can only imagine the sheer power imbalance. A large B-47 bomber with a single Iroquois strapped to its tail. But tragically, this incredibly ambitious program came to an abrupt and devastating end, didn't it? The Aero cancellation.
Yes. On February 20, 1959, in a decision that continues to be, a hugely significant moment in Canadian aviation history, Prime Minister John Diefenbaker's government abruptly announced the cancellation of both the advanced Avro Aero project and the groundbreaking Iroquois engine program.
Just pulled the plug.
Just like that. The very first Mark II Aero airframe, RL-206, which was specifically designed to be powered by the Iroquois engines, was just mere weeks away from commencing its highly anticipated flight trials.
Weeks away. Oh, that's heartbreaking.
A truly devastating blow, not only to Orenda and Avro, but to the entire Canadian aerospace industry and the immense potential it represented. But, remarkably, Orenda managed to weather this storm and survive, didn't they? How?
They did. In 1955, even prior to the devastating Aero cancellation, a significant reorganization took place that formally established Orenda Engines as a distinct and separate entity within Avro.
Because they were already sort of their own unit.
Kind of. And while the cancellation of the Aero and the Iroquois was undoubtedly a massive setback, Orenda had wisely cultivated a substantial and reliable engine overhaul and repair business. That basically proved to be their lifeline during this turbulent period.
Ah, the repair side. Smart move.
This pivot from solely focusing on new engine development to also maintaining and upgrading existing engines was a crucial strategic move that ensured their survival.
So they strategically shifted their focus towards the maintenance and upkeep of existing engines to stay afloat. Less glamorous, maybe, but necessary.
Precisely. And they also successfully secured crucial contracts to build engines under license for other aircraft programs. A pivotal moment arrived in the late summer of 1959 when the RCAF selected the Lockheed F-104 Starfighter as their new high-performance day fighter.
The Starfighter, the missile with a man in it.
That's the one. Canadair was awarded the contract for its Canadian production. Importantly for Orenda, they were awarded the contract to manufacture the Starfighter's powerful General Electric J79 engines. The Canadian government had already proactively negotiated a production license agreement with GE.
So building American engines under license.
Yep. By December 1960, Orenda had completed the first 5 of these J79 engines, and they went on to produce nearly 480 of them by the mid-1960s, providing a significant and much-needed source of work.
That represents a substantial production run, demonstrating their continued manufacturing capabilities even after the Iroquois. They also built engines for other significant Canadian aircraft designs, correct? Like trainers.
Yes. In the early 1960s, Orenda also successfully won the contract to produce the General Electric J85 engine for the Canadair CL-41 Tudor jet trainer aircraft.
The snowbirds fly those, right?
It did.
Exactly. Right. It became the standard pilot training aircraft for the RCAF for many years. The first of these engines, designated J85 Sienna 40, was delivered in September 1963, with the final one following in October 1965.
Okay. Subsequently, when Canadair secured a license to produce the CF-5 fighter aircraft, a derivative of the Northrop F-5 for the RCAF in 1967, Orenda began manufacturing the more powerful afterburning J85 CAN-15 variant for this aircraft.
Another licensed build.
Between June 1967 and May 1974, they manufactured an impressive total of 609 of these J85 engines, not only for the Canadian Armed Forces, but also for the air forces of the Netherlands and Venezuela, highlighting their continued international significance.
So, even in the aftermath of the Aero's cancellation, Orenda remained a vital and active player in the production and maintenance of military aircraft engines, both domestically and internationally. But their diversification efforts extended beyond just aircraft engines, didn't they? You mentioned industrial uses.
They did indeed. Beginning in the early 1960s, Orenda made a strategic decision to leverage their gas turbine expertise by diversifying into the field of industrial gas turbine packages.
Like for power plants or pipelines?
Exactly. These robust and reliable turbines found a wide range of applications, including driving gas compressors for natural gas pipelines, powering pumps for oil pipelines, and generating electricity. They developed their own successful OT series of industrial turbines.
OT series?
For example, the OT2 turbine was supplied to TransCanada Pipelines for their extensive natural gas network, while the National Research Council of Canada received the OT3 for various research applications. The OT5 turbine was specifically designed for the modernization of the Pine Tree Line.
The Pine Tree Line, the Cold War radar network?
That's it, the joint U.S.-Canada early warning radar network. And notably, the OT5 featured cogeneration technology, where the waste heat from the turbine's exhaust was recovered and used as significant Canadian first in that particular application of gas turbines.
Cogeneration, very efficient.
Yeah. Between the 1960s and 1970s, Orenda delivered roughly 175 of these industrial turbines to a diverse array of customers both within Canada and internationally. It demonstrated a successful transition into new markets for their core technology. This diversification proved to be a crucial element in Orenda's long-term viability.
It sounds like they were effectively applying their expertise in gas turbine technology to a range of new and important industrial applications. What about the OT4 project? That seems like another intriguing, though perhaps less well-known endeavor. Was that industrial too?
The OT4 was conceived as a versatile, multi-purpose gas turbine developed by Orenda in the 1960s, initially to meet a specific requirement from the United States Navy for new, more powerful engines to equip their next generation of mine-sweeping vessels.
Minesweepers. Interesting application.
Yeah. With financial support from the Canadian government, Orenda secured a development contract in 1961 alongside two American companies who were pursuing competing designs. Interestingly, the United States Army also explored the potential of adapting a version of the OT4 for use in their main battle tanks.
Tanks too. Wow. Versatile.
The U.S. Navy investigated a variety of other applications, from powering large landing craft to advanced hovercraft and hydrofoil vessels. There were even promising trials conducted using a re-equipped coastal minesweeper, the USS Bittern, with reports indicating fairly successful performance.
So it worked.
It seemed to. Orenda also partnered with an American heavy truck manufacturer to examine its potential in road transport, with road tests of an OT4-powered truck taking place in Canada in 1967.
A jet-powered truck.
Sort of.
Yeah.
Gas turbine, technically. Furthermore, two M48 patent tanks were reportedly tested to evaluate the OT4's performance under extreme hot and cold environmental conditions. However, despite these promising leads and trials, all of these OT4-related efforts ultimately concluded in September 1967.
Ah, so another what if. Why did it end?
The U.S. Army determined that the OT4 didn't quite offer the necessary power output for their future tank designs, and the U.S. Navy shifted its mine warfare strategy towards using helicopters more, which reduced the need for advanced turbine-powered minesweepers.
So a series of promising opportunities that ultimately didn't fully materialize into large-scale production. It sounds like a common narrative in the often risky world of technological development, doesn't it?
Absolutely. But there was also some licensed production of Orenda designs happening overseas, wasn't there? Back to Belgium.
Yes, that's correct. F.N. Herstal, the well-known Belgian arms manufacturer, undertook licensed production of the Orenda 11 jet engine for aircraft propulsion.
Orenda 11,
Yeah.
So a variant of the main Orenda.
Yeah. This engine produced a respectable 33 kilonewtons of thrust. They commenced building these engines in 1954, and they were primarily used to power the Belgian Army's fleet of CF-100 Canuck interceptor aircraft.
Ah, for their Canucks. Makes sense.
Interestingly, the design of the Orenda 11 was largely based on Frank Whittle's pioneering W.1 engine, one of the earliest jet engines.
Back to Whittle again.
Yeah. However, the Orenda 11 incorporated several modifications to its compressor, turbine, and combustion chambers, potentially incorporating design elements influenced by the German Junkers Jumo 004 engine.
The first operational jet engine.
Exactly. Examples were captured by the Allies during World War II and extensively studied. This highlights a fascinating lineage connecting Orenda to the very foundations of jet engine technology.
So a direct link back to the earliest days of jet propulsion. Now, what about the later history of Orenda? We know that today they are part of a larger aerospace group, right? Magellan.
In the 1980s, a new entity called Magellan Aerospace was formed, primarily through the acquisition of assets from the Canadian operations of Fleet Aerospace. Over the subsequent years, Magellan significantly expanded its operations through a series of strategic acquisitions, and this growth included Orenda.
So Magellan bought Orenda.
Yep. They subsequently renamed it Orenda Aerospace, and later as Magellan Repair, Overhaul, and Industrial. Magellan continued to operate out of the historic Malton Building, a site steeped in aerospace history, until 2018.
Still in the old building until recently?
Oh, yeah. At that point, they constructed a brand new, state-of-the-art facility on the same land in Malton. Sadly, the original Avorenda factory building, which had stood for over 80 years and witnessed so much innovation, was finally demolished in 2020.
So the direct physical connection to that remarkable early history is now gone, although the legacy lives on in the same location. What about Orenda's own engine design and development efforts in more recent times? Did they try again after the Iroquois?
In the 1990s, Orenda Aerospace made an attempt to re-enter the market for reciprocating engines with the development of the OE600.
Reciprocating, like piston engine.
Exactly. This was a new, relatively powerful 600 horsepower, 8-cylinder engine specifically designed for general aviation aircraft. However, the prevailing market conditions in the aftermath of the 9/11 terrorist attacks proved to be particularly challenging for this sector.
Tough timing again.
Yeah. Consequently, the OE600 program was put on hold in 2005 as the company shifted its focus towards more immediately viable military contract opportunities. Eventually, in 2007, all the intellectual property rights and assets related to the OE600 design were sold to a company called Trace Engines, based in Texas.
So that engine didn't quite take off either. And finally, we can't overlook the intriguing and persistent stories, almost like modern urban myths, that have long surrounded the old Orenda plant, the legendary secret tunnels. What's the real story behind those tales? Any truth to them?
Ah, yes, the captivating secret tunnels of Orenda. This is a topic that has certainly captured the public imagination and fueled much speculation over the years. We do have concrete confirmation of at least one substantial tunnel that connected the main Avro aircraft manufacturing plant with the adjacent Orenda engine facility.
Okay, one tunnel confirmed. Why was it built?
It was a practical and efficient solution to transport the large and heavy engines across what is now Airport Road, undoubtedly for logistical efficiency and perhaps also for security reasons, during the Cold War. This tunnel was reportedly large enough to accommodate rail tracks, allowing engines to be moved between the two facilities on specialized carts.
But the rumors and anecdotal evidence seem to suggest the existence of a more extensive network of tunnels than just that one documented link, don't they? People talk about more.
They certainly do. There have been persistent stories, often recounted by former employees and local residents, about the potential existence of other tunnels branching out from the main Avro and Orenda sites. These rumored tunnels supposedly include one running underneath the International Center, which incorporates one of the original Avro hangars into its complex.
Under the convention center.
Yeah. And even a much longer tunnel, allegedly stretching all the way to Toronto Pearson International Airport. There are even more contemporary claims suggesting that the Canadian Border Services Agency, which has offices located near the International Center, might still be utilizing some of these older tunnels for secure access to the airport.
Wow. Still in use. That's wild if true.
And adding another layer of intrigue, during the demolition of the old Orenda plant buildings in 2020, a large and unexpected underground concrete structure, often described as a massive basement or subterranean level, was discovered, further fueling these long-standing speculations about hidden infrastructure beneath the site.
A huge hidden basement.
Yeah.
That definitely adds fuel to the fire. It's truly fascinating to contemplate what might still exist hidden beneath the surface of that historic site. And we even have a personal connection to this aspect of the story, don't we?
We do indeed. Jerry Legree, a commenter on a blog post that discussed the history of the Orenda factory, shared a personal anecdote that her father worked at the Orenda plant during the intense period of Avro aero testing and development, and that her aunt was also employed in the administrative offices located in Moulton.
Wow, family connections right there.
These personal connections really help to humanize the historical accounts and add another layer of authenticity to the discussions surrounding the tunnels and the overall atmosphere of the plant during that era.
It really does bring the human element to what can sometimes feel like a purely technical or historical narrative. And it seems there was still a significant amount of physical material from Orenda's long history stored underground right up until the demolition of the old plant. Did they save anything?
That's correct. Robin Sipes, who is well known for his dedicated efforts in recovering a long-lost Iroquois engine.
Right, the guy who found the Iroquois.
Exactly. He mentioned that he was invited to the old Orenda plant site prior to its demolition in 2020. His mission was to recover any remaining Orenda engine parts from a below-ground storage space. He described encountering a mind-boggling amount of material that had been stored there over the decades.
Mind-boggling.
Truly highlighting the sheer scale of Orenda's operations and the vast amount of historical artifacts that were once present at the site. While sadly, no components from the elusive Iroquois engine were found in that particular location, it certainly underscores the immense history that was contained within that now demolished factory.
So, from its wartime origins and its pivotal role in powering iconic aircraft like the Avro Aero, to its subsequent successful diversification into industrial applications, Orenda Engines undeniably left an indelible and lasting mark on the landscape of Canadian aerospace history and technological innovation. Even though the original factory buildings are now gone, its legacy as a hub of engineering excellence continues through its current iteration as part of Magellan Aerospace.
Absolutely. The remarkable story of Orenda serves as a powerful reminder of the immense talent, ingenuity, and ambition that has long existed and continues to thrive within the Canadian aerospace sector. It also compels us to reflect on the profound and far-reaching impact of significant decisions like the cancellation of the Aero and the Iroquois program,
Yeah.
and to ponder the different paths that might have been taken and the alternate technological landscape that could have emerged.
It truly makes you wonder, doesn't it? What other groundbreaking Canadian innovations might have soared to global prominence and transformed industries under slightly different circumstances? The compelling story of Orenda Engines stands as a powerful testament to Canadian engineering prowess, a journey defined by remarkable ambition, significant achievements, and a lasting impact that continues to resonate today.
And now, as our in-depth exploration of Orenda Engines draws to a close, we want to invite you, our listener, to keep that spirit of curiosity and discovery alive. If you've been inspired by the soaring story of Canadian innovation we've uncovered today, then the All Sorts podcast is kind of your ongoing launchpad to countless other fascinating deep dives into the world around us.
That's right. Join our growing community of curious minds by hitting that like button, sharing this deep dive with anyone who might find it interesting, and subscribing to the All Sorts podcast on YouTube so you never miss an upcoming exploration.
Yeah, definitely subscribe.
Dive deep into our extensive archive of previous podcasts. There's a universe of knowledge waiting for you. And be sure to follow the All Sorts podcast on X, Instagram, and Threads to stay connected, share your thoughts, and become part of the ongoing conversation. Let's continue to explore the fascinating tapestry of our world, one deep dive at a time.
Thank you for joining us on this deep dive into the remarkable history of Orenda Engines. Until our next exploration, keep those questions coming and your minds open to the endless wonders that surround us.